Human beings measure their intelligence in patterns. When we look at a Mensa test, it's all about pattern recognition. When we look at standardized examinations, it's about understanding and recognizing patterns and returning the patterns to the answers. And chess is a fantastic example of pattern recognition. The difference between a grandmaster in chess and a very good chess player is the ability for the grandmaster to understand and recognize and memorize the patterns of all the previous moves that are available on a 64 square board. They go off and they memorize all the possible patterns that they can. And they memorize how that is going to be deployed in their strategy. And it leads to a very, very, very strong player. And when we think about patterns, when we bring it in, we can use technology to do the same thing. There was a software application developed called Stockfish 8, and it was written by grandmasters and programmers to learn all the chess moves and to have all the plays in the background, so it knew all the patterns of chess. And for about 10 years, it was unbeatable. It would beat all the grandmasters in chess. It could compute about 600,000 moves a second and understand how to play the chess and how to win the game based on all the patterns that human beings had given it and understood what it was. Amazing technology. It could sit in the laptop and you could play chess against it and it would beat you every time because it had the knowledge of the grandmasters in its head. In about 2016, Google turned around. They developed an AI called AlphaZero. And AlphaZero was an AI, just a blank AI, just to go off and play games. They've used the same AI to play Go and to play other sports as well, other mind games as well. And they gave AlphaZero the rules of chess. And they said, there you go, AlphaZero. Here are the rules of chess. Knock yourself out. Go play some games. And AlphaZero went off and it played hundreds of millions of games against itself. And then they put it up against Stockfish 8 and they played 100 games of chess. And AlphaZero beat it 100 times in a row. And that's an incredible feat for an artificial intelligence to learn the rules of a game and then to go and beat the grandmaster computer of that sport 100 times in a row. But what's truly amazing about this is not the fact that it beat it. It's the fact that it learned chess, learned the rules of chess, played hundreds of millions of games itself, and then beat the reigning computer champion 100 times in a row in 9 hours. It did all of that in 9 hours, which is phenomenal. The pattern recognition of an artificial intelligence is what gives it its power. It's what gives it its intelligence. And you could say, well, that's only 64 possible squares, there's X number of combinations. How the AI learned the game was what's impressive. How it learns to change the rules of the game and the recognized strategy. It sacrificed more pawns than any grandmaster ever would. It sacrificed more players than any other player would, but it won 100 times in a row. And it's this power that we use to exploit the power of AI. And AI is something that we teach every day. Google gave AlphaZero the rules of chess and let it go off and play. And every day we give AI rules. So if you look here, we have a CAPTCHA slide. And in a CAPTCHA slide, we teach an AI. We give it more information in its model to understand patterns. So in this particular CAPTCHA, it's looking for bicycles and it's looking for human beings to identify the bicycle. And you may often wonder, why do these CAPTCHA things happen? How is this adding value to me, as a password to get into something? But this information is being used, A, to identify human beings, so they have good knowledge of understanding that this is a bicycle, or this is a cat, or this is a door, or a light, or a traffic light, or a crossway, or whatever it may be. And the more and more times that we show the AI what a bicycle is, the more situations it can recognize a bicycle. This information then is used by the car manufacturers in the automotive industry to train their autonomous vehicles. So we are training AI all the time to recognize patterns, even when we don't know it. And this is a very important fact when it comes to the autonomous vehicles, because we are putting them out into an unpredictable and chaotic world that has a limited amount of rules, i.e. drive on the road, not the footpath, drive on the left or the right hand side of the road, stop at a red light, don't crash into another moving vehicle. And we're training it all the time as to what's right and what's wrong. And the AI is learning from these patterns and developing an intelligence to let it survive in the world. And you're looking at me and you're saying, right, Simon, this is a construction, talk, a construction conference. This has nothing to do with what we do. But the chaos of transport is very analogous to what we do. When we look at construction today, there is lots of sources of chaos within our industry. We are doing things the way we've always done them. We've built patterns on how things should work, and we're working all the time to try and mitigate those risks. If we look at design and engineering, there's issues that can arise with the design and the engineering phase where we don't see something. So the likes of Firmus, which is an AI company, they will take your models that you've worked on. So let's say, for example, you've built a lot of schools or a lot of hospitals. They will take your previous models and analyze all those models and see where you have missed features in the past. So, for example, you may have forgotten to put in a fire dampening unit or an opening for some ducting or something like that. And they will understand how your design company builds things and understand the complexity of a building, so where the most errors might happen. And you can put a new design into their AI, and it'll compare your style of construction, your style of engineering with your new one, understand where you've made mistakes before, where you've had issues before, and identify those in your new design before they leave your design house, before they leave your engineering facility. So they can look at thousands of drawings. If you have a complex hospital with thousands and thousands of rooms in it, it can go in very quickly, in a matter of minutes, look through all your models and identify issues that you may have from previous work. So, for example, fire dampers. If you have in the past, had difficulty installing fire dampers or forgot to put them in relevant rooms, or you expect to see a fire damper in a particular corner of a room consistently, the AI will go and look at that and say, hey, should you not have a fire damper in this room? Should there not be one in this corner? So here the AI is looking at the patterns of your design style, your design capabilities, and it's quickly running a cautious eye over everything to understand if there's any risk in issuing the models that you've created so that they don't come back to you with a problem in them. And this is very important for design companies, and it makes a huge difference to the work coming back, because every company wants to do something once and to minimize the errors that they issue out to the clients. The same thing happens within construction and assembly, and I've only picked 2 or 3 samples here. But if I look at Autodesk have an AI that runs in the background called Construction IQ. And Construction IQ not only will look at a project and look at the number of checklists that are completed or the number of issues or snags that are raised on a project, it'll look at how often those issues are closed, how complete your checklists are. It'll look at the delay in resolving issues on your project. How long does it take? It will look at all the paperwork on your project. Are the RFIs being answered? Are you getting drawings on time? Are there many issues linked to a particular drawing? Are your submittals being closed out in time? Are your RFIs being answered? And it'll assess all of this information at a project level across the project to understand the risk to your project being completed on time and on date. It's an important factor. Not only that, it'll look across your entire enterprise and look at all your projects and highlight the projects where it believes there's a risk to the project from either the contractor or the design team or the subcontractors, depending on their performance. And this is a very useful tool for management to understand and to mitigate the risk from the thousands and thousands of issues that are raised on a project, from the thousands and thousands of documents that are transferred. It allows them at a very high level to gather a massive amount of information and to look for the patterns in those projects which will signify a risk to the delivery of that project. And we can go then to the likes of SmartVid.io. SmartVid.io is another application that's a visual-based learning tool, AI tool. And what it does is it takes imagery from the site and it will apply the AI to that imagery. So if, for example, you want to track progress of the model, you can go around your site, take imagery of your project, and it will automatically compare it to your model and will identify where there's differences. Is your project on time? Is your project, does your as-built reflect the model accurately? Have they built what's supposed to build? And from a safety point of view, it can automatically track masks on people or gloves or goggles or any of those things that may cause or impose a risk to your project. And then in the final building, within BAM ourselves, we've developed an AI for road maintenance. So BAM, not only is BAM a construction company, we're also a operational company, operational maintenance company. And In BAM Netherlands, they've developed an artificial intelligence that will look at video footage from roads, from highways, and will ascertain the location and the severity of potholes or damage to the roads from people just driving along that. Now, I've picked 3 or 4 examples here of what could be, of what is in our current situation, where we're trying to apply intelligence to the chaos of our process to understand how we can be more productive with the problems that we face today. And I've left out some gaps here where they are, for example, supply of materials or development or the material distribution and so on. There are other artificial intelligence agents out there that will cover those, especially for logistics. But where we are today with construction is very much the older style of construction. It's very much going back to the Egyptian picture you can see at the bottom there, where we're not maximizing our potential for construction. What we're doing is we're making the most of what we have. We're looking at the patterns that we've always used and we're trying to maximize them through the use of artificial intelligence, through the use of digital technology and lean thinking to improve what we do. But the reality is, in the future, we have to get to the situation where our productivity matches our demand and our need. Industrial construction is where we apply a standard approach and a commoditized approach towards construction. And we take away a lot of the chaos that exists in today's market and make it a much more standardized platform. And the question that we have really is not how we're going to apply AI or where we're going to apply AI. The reality is that because this is going to be a standardized system and because we're going to see so much more conformity and continuation of things, we don't know where AI is going to be applied. It's going to be applied across all of it, simply because the benefit of AI is that it takes the chaos of a situation and applies some order to it by identifying the patterns and identifying where we can minimize or mitigate risk or where we can identify or maximize our productivity.